David Smith here with another flipped classroom math video. A few tips before we start. Remember that you can speed up or slow down the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain. Lastly, you can turn on the captions and follow along with my words on the bottom of your screen. Today we're going to dive into rational functions and tease out various characteristics and parameters of them. So mostly what we're going to talk about is domain range, asymptotes, and graphing. So this is kind of going to be a soup to nuts explanation of the things that you can do with a basic rational function. And then later in this chapter we'll get into the more complicated ones. But right now we're just starting with a rational function in the form f of x equals some constant k over x. And you'll notice that our variable is in the denominator of a fraction. So that's what makes it a rational function, and that's what gives it its unique graph, its unique behavior. So let's take a look. Actually, pause the video for a sec. Think about the domain of this function. Are there any limitations on the domain? So hopefully you realize that you can put any number you want in for x except 0. We can't divide by 0 in mathematics. So you can say x is an element of real numbers and x is not equal to 0. Now, take a look or think about what's the range. So when you put all those possible values for x, what would f of x be or what would y be? Are there any limitations on our range? All right, y has the same restriction but for a different reason. So pretty much you can get anything out of this function except 0. As x gets ginormous, really big, k over x, remember k is a constant, doesn't change, k over x gets really small. So this number is going to go towards 0, but as long as there's a value in here, it will never quite touch 0. And the same thing going the other way. As x gets very small, y gets very big. And so y will approach infinity. And then the same works for negative x, either getting big or small, so we can approach infinity or 0 from the negative side. So again, y is an element of all real numbers, just will never be 0. So here's our two limitations for a domain and range for our basic k over x. All right, I would like you to get out your graphing calculator or use Desmos or whatever tool you have handy, and I would like you to go ahead and graph that with your technology and then go ahead and sketch it on your page. All right, remember, sketch is a command that basically says just throw that on there. You don't need a lot of information. So all I did is I sketched my graph from my graphing display calculator there, and you can see that when x is in the positive realm, it either approaches 0 as x gets it approaches infinity as x gets very small, and it approaches 0 as x gets very big. So that's what we discussed before. And then when x is negative, it does the same thing, except now it's in quadrant 4 instead of quadrant 1. So there's a graph of 12 over x. Get used to these discontinuous graphs. What that means is that it's not one line that's all connected up. We have this line and that line for this function, or these curves, I should say. Now check this out. There's this idea of an asymptote, and there's two here. If you remember that, pause the video and write down the equations for the asymptotes. So, asymptotes come in two flavors. We have vertical asymptotes and horizontal asymptotes. And what an asymptote is it's either a vertical or a horizontal line that the function approaches infinitely closely but never gets to. So again, in this function, as x gets super large, the function's value approaches 0. So as x is getting large, going way out the x-axis, this line is getting closer and closer to the x-axis, but doesn't touch it. That's what an asymptote is. And you're going to be asked to generate equations for asymptotes. So in this super simple function, the equation of the horizontal asymptote is y equals 0. So a lot of times what you need to do is sketch your asymptotes using dashed lines. This one is superimposed over the x-axis, so it gets a little confusing. Later when we do more complicated functions, that asymptote is going to shift up and down, as the vertical asymptote will shift right and left. So let's take a look at that vertical asymptote. This is when the function's value itself goes to negative infinity or to positive infinity. So that's as x gets very, very, very tiny in the positive direction, it's going to approach positive infinity, and so on in the negative direction. So our vertical asymptote is the y-axis, where x equals 0, and I could sketch that line basically right over the y-axis, and that's the vertical asymptote. So this function, while very basic, it illustrates everything that we need. We've graphed it, we've marked our asymptotes, we've written our equation and all of that. Now later, we're going to talk about how when a function crosses an axis, and we do need to delineate the intercepts as well. Okay, so now what I'd like you to do is pull out your display calculator or Desmos, and I'd like you to go ahead and make a sketch of that graph. So all I did is I just changed the 12 to a negative, and before you do that, think in your mind, make a prediction about what that graph might look like, and then use your tools, graph that, jot it down in your notes, and come back to the video. All right, so you can see this graph hasn't changed much, it's just reflected across the y-axis. Our curve was in here, now it's reflected across to here, and the other part of the curve was here, and it's reflected across here. And all that's happening, let's take a look, as x gets very, very large, you remember how the curve was approaching 0, but now that it's negative, the y value was approaching 0. Now the y value is approaching 0 as x gets negative. So that's why this curve is over here, and a similar explanation happens for that curve. Now, what I'd like you to do is, on the same graph, is go ahead and plot f of x equals negative 4 over x. And before you do that, make a prediction about how this curve will be different from that curve. Do that and then come back. All right, so the asymptotes are going to stay the same because the equation is essentially the same, very straightforward equation. But what's happening is when I decrease this number, the curve is coming in closer to the origin. The asymptotes are the same. All right, let's do one more. Let's do f of x equals 0.25 over x. Now, before you do that, make a prediction for what that graph is going to look like with respect to this setup, the two graphs we already have. Okay, so the prediction was, since we don't have a negative, it's going to go back in quadrants 1 and 3, like our first example, and then this number got smaller. Remember, we went from negative 12 to negative 4. Now we went to negative 1/4. So again, the curve is going to get closer and closer to the origin. So think for a minute if you could write a description of what the k does. Remember, we have a graph, a function in the form of f of x equals k over x. So take a minute and see if you could write like a really concise little mathematical statement about what k does. Here you go. A little wordy, but it captures the essence of it. So, for functions in the form f of x equals k over x, as the function approaches infinity, and I should say from positive infinity and negative infinity, but this will do, the function itself gets further and further from the origin. So that curve is pushing out from the origin. Conversely, as k approaches 0, the function is going to get closer and closer to the origin. We showed that on the graph. You can also look at that mathematically with the value of the function, and you'll reach the same conclusion. Now that you've finished, take a moment to write down any questions so you can bring them to our next class and get some help. You can also watch the video again to improve your understanding. If you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.